Hello, and I want to welcome you to a discussion on logarithmic functions. So let's get started. Okay, here's the definition of a logarithmic function, and here are some sample uh, vocabulary words that you would like to know for the term of the course. And something interesting that you would like to take note of is that when y equals log, where the base is b, x, that equivalates to base of b to the y power equals x. So essentially what happens is that b moves this direction, and the equals becomes the x. And this is the exponent that moves. Okay, so if we take that note, we can do these examples first to write the equation in its equivalent exponential form. So if we take what we have, we want to take the base of our log, which is 6, to the power that is here for the second equals 36. We'll do the same thing for number 2. Have our log come out in front, follow with our equal sign equaling 8. So we're going to have our base of 2 to the power of 3 equals 8. Number 3, 2 will become our base. Our equals will become 16. So base of 2, power of y equals 16. Now later on we'll try to solve for y, but for now we're just going to keep working with writing things in the log form. With our second set of examples, we'll write the equations in its equivalent logarithmic form. So we're taking what we have, and we have to work backwards. So our base in this case will be 2. Okay, and then we have to write the number that it's equal to, 64, and then we're actually going to set it equal to the power, which is 6. Okay, so looks like our base in this case for number 2 will be 4 with what we're equaling to, x, and then we're set it equal to our exponent of 3. With number 3, looks like we're going to have a log base of z set aside 5, 12, and then we're going to set it equal to our exponent of 9. Okay, and finally, with number 4, looks like we're going to have a log of 6. Then we're going to have the number that it's going to be equal to, 1 over 216, equaling our power of negative 3. Moving on, logarithms can be equated by rewriting the exponential form. So the examples find the exact value of the logarithm without using a calculator. And this is really easy to do. With our log, first what you want to do is take your log base of 4, 1024, and set it equal to x. Now you can use that your base is 4 with the base of x, or with the exponent of x equals 1024. Now the goal is to find what power, having a base of 4, would 1024 be? Well, that's actually equivalent to 4 to the 5th power, because 4 to the 5th power is equal to 1024. So now that our bases are the same, we can take our powers of x and 5 and bring them down and just solve for the variable, and it's already solved, so it's x equals 5. Okay, let's repeat that same with number 2, log base 7 to the power of 1. So let's set it equal to x, and so we're going to have 7 as a base to the power of x equals 1. Well, if you think about it, 1 can't be written to 7 can't be written as a base of 1 to any power. So what does x have to be? In this case, x is actually going to be equal to 0. And finally, for number 3, we have log base of 64, 8. So we're going to set it equal to x. So we have 64 power of x, power of x equals 8. Well, 8 can't be written any further than it is to have a still base of itself, so we have 1. So we can rewrite 64 as a base of 8 to the power of 2, and then we'll just have our x in there. So now that our base is the same, we can rewrite 2x equals 1. We just took the powers, and now we can solve for the variable by dividing by 2 on both sides. And when we do that, we get that x is equal to 1/2. And finally, for this video, we're going to talk about the domain of a logarithmic function. In part 2 of the video, we will discuss the properties of logs, and we'll do some natural logs, some examples, and that will be about it. But to conclude with this portion of the video, the domain of a logarithmic function. So what you really want to gather is that if you take what's inside this parentheses right here, where x plus 4, and you want to say that it is greater than 0. Now solve for the variable by subtracting 4 on both sides. So x is greater than -4, and that is the domain of that function. Looking at number 2, we have x minus 0. So we can say that 2 is greater than 0. Now solving for x, subtract 3 on both sides. When you do that, you have -x is greater than -3. Now, we need to change the sign of x for it to be a positive x, and when you do that, you're also going to get a positive 3. Now, you're going to change the sign of the inequality. So x is less than 3 is the domain of that function.